Department for Education, Mathematics Programs of Study, Key Stage 3, National Curriculum in England, September 2013. Mathematics, Key Stage 3. Purpose of study. Mathematics is a creative and highly interconnected discipline that has been developed over centuries, providing the solution to some of history's most intriguing problems. It is necessary in everyday life, critical to science, technology and engineering, and necessary for financial literacy and most forms of employment. A high-quality maths education, therefore, provides a foundation for understanding the world, the ability to reason mathematically, an appreciation for the beauty and power of mathematics, and a sense of enjoyment and curiosity about the subject. Aims. The National Curriculum for Mathematics aims to ensure all pupils become fluent in the fundamentals of mathematics, including through varied and frequent practice with increasingly complex problems over time, so that pupils develop conceptual understanding and the ability to recall and apply knowledge rapidly and accurately. Reason mathematically. By following a line of inquiry, conjecturing relationships and generalizations, and developing argument, justification, or proof using mathematical language. Can solve problems by applying their mathematics into a variety of routine and non-routine problems with increasing sophistication, including breaking down problems into a series of simpler steps and persevering in seeking solutions. Mathematics is an interconnected subject in which pupils need to be able to move fluently between representations of mathematical ideas. The program of study for Key Stage 3 is organized into apparently distinct domains, but pupils should build on Key Stage 2 and connections that cross mathematical ideas to develop fluency, mathematical reasoning, and competence in solving increasingly sophisticated problems. They should also apply their mathematical knowledge in science, geography, computing, and other subjects. Decisions about progression should be based on the security of pupils' understanding and their readiness to progress to the next stage. Students who grasp concepts rapidly should be challenged through being offered rich and sophisticated problems before any acceleration through new content in preparation for Key Stage 4. Those who are not sufficiently fluent should consolidate their understanding, including through additional practice before moving on. Information and Communication Technology, ICT. Calculators should not be used as a substitute for good written and mental arithmetic. In secondary schools, teachers should use their judgment about when ICT tools should be used. Mathematics, Key Stage 3. Spoken language. The National Curriculum for Mathematics reflects the importance of spoken language in pupils' development across the whole curriculum, cognitively, socially, and linguistically. The quality and variety of language that pupils hear and speak are key factors in developing their mathematical vocabulary and presenting a mathematical justification, argument, or proof. They must be assisted in making their thinking clear to themselves as well as others, and teachers should ensure pupils build secure foundations by using discussion to probe and remedy their misconceptions. Attainment targets. By the end of Key Stage 3, pupils are expected to know and apply and understand the matters, skills, and processes specified in the relevant program of study. Schools are not required by law to teach the example content in square brackets or the content indicated as being non-statutory. Key Stage 3. Working mathematically. Through the mathematics content, people should be taught to develop fluency, consolidate their numerical and mathematical capacity from Key Stage 2, and extend their understanding of the number system and place value to include decimals, fractions, powers, and roots. Select and use appropriate calculation strategies to solve increasingly complex problems. Use algebra to generalize the structure of arithmetic, including to formulate mathematical relationships. Substitute values in expressions to rearrange and simplify expressions and solve equations. Move freely between numerical, algebraic, graphical, and diagrammatic representations, for example, equivalent fractions, fractions and decimals, and equations and graphs. Develop algebraic and graphical fluency, including understanding linear and simple quadratic functions. Use language and properties precisely to analyze numbers, algebraic expressions, 2D and 3D shapes, probability, and statistics. Reason mathematically, extend their understanding of the number system, make connection between number relationships and their algebraic and graphical representations. Extend and formalize their knowledge of ratio and proportion in working with measurements and geometry, and in formulating proportional relations algebraically. Identify variables and expression and express relations between variables and algebraically and graphically. Make and test conjectures about patterns and relationships. Look for proofs or counterexamples. Begin to reason deductively in geometry, number, and algebra, including using geometrical constructions. Interpret when the structure of a numerical problem requires additive, multiplicative, or proportional reasoning. Explore what can and cannot be inferred in statistical and probabilistic settings, and begin to express their arguments formally. Solve problems. Develop their mathematical knowledge in part through solving problems and evaluating the outcomes, including multi-step problems. Develop their use of formal mathematical knowledge to interpret and solve problems, including financial problems. Begin to model situations mathematically and express the results using a range of formal mathematical representations. Select appropriate concepts, methods, and techniques to apply to unfamiliar and non-routine problems. Subject content. Number. Pupils should be taught to understand and use place value for decimals, measurements, and integers of any size. Use positive and negative integers, decimals, and fractions. Use the number line as a model for ordering real numbers. Use the symbols equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. Use the concepts and vocabulary of prime numbers, factors or divisors, multiples, common factors, common multiples, highest common factor, lowest common multiple, prime factorization, including using product notation and the unique factorization property. Use the four operations, including formal written methods applied to integers, decimals, proper and improper fractions, and mixed numbers, all both positive and negative. Use conventional notation for the priority of operations, including brackets, powers, roots, and reciprocals. Recognize and use relationships between operations, including inverse operations. Use integer powers, associated real roots, square, cube, and higher. Recognize powers of 2, 3, 4, 5, and distinguish between exact representations of roots and their decimal approximations. Interpret and compare in standard form a times 10 to the power n, where a is greater than or equal to 1, but less than or equal to 10, less than 10, where n is a positive or negative integer or 0. Work interchangeably with terminating decimals and their corresponding fractions, such as 3.5 and 7 divided by 2, or 7 halves, or 0.375 and 3/8. Define percentage as number of parts per hundred. Interpret percentages and percentage changes as a fraction or a decimal. Interpret these multiplicatively. Express one quantity as a percentage of another. Compare two quantities using percentages and work with percentages greater than 100%. Interpret fractions and percentages as operators. Use standard units of mass, length, time, money, and other measurements, including with decimal quantities. Round numbers and measurements to an appropriate degree for accuracy, for example, the number of decimal places or significant figures. Use approximation through rounding to estimate answers and calculate possible resulting errors expressed by using inequality notation. Use a calculator and other technologies to calculate results accurately and then interpret them appropriately. Appreciate the infinite nature of the sets of integers, real and rational numbers. Algebra. Pupils should be taught to use and interpret algebraic notation, including a b in place of a multiplication symbol b, 3y in place of y addition symbol y, and 3 multiplication symbol y. A squared in place of a multiplication symbol a, comma, a to the power 3 in place of a multiplication symbol a, semicolon, a squared b in place of a multiplication symbol b, a over b in place of a division symbol b, coefficients written as fractions rather than as decimals, brackets. Substitute numerical values into formulae and expressions, including scientific formulae. Understand and use concepts and vocabulary of expressions, equations, inequalities, terms, and factors. Simplify and manipulate algebraic expressions to maintain equivalence by collecting like terms, multiplying out a single term over a bracket, taking out common factors, expanding products of two or more binomials, understand and use standard mathematical formulae, rearrange formulae to change the subject. Model situations or procedures by translating them into algebraic expressions or formulae and by using graphs. Use algebraic methods to solve linear equations in one variable, including all forms that require rearrangement. Work with coordinates in all 4 quadrants. Recognize, sketch, and produce graphs of linear, quadratic, and quadratic functions in one variable with appropriate scaling, using x and y and the Cartesian plane. Interpret mathematical relationships both algebraically and graphically. Reduce a given linear equation in 2 variables to the standard form y equals mx plus c. Calculate and interpret gradients and intercepts of graphs of such linear equations numerically, algebraically, and graphically. Use linear and quadratic graphs to estimate values of y for given values of x and vice versa, and find approximate solutions of simultaneous linear equations. Find approximate solutions to contextual problems from given graphs of a variety of functions, including piecewise linear, exponential, and reciprocal graphs. Generate terms of a sequence from either a term-to-term or a position-to-term rule. Recognize arithmetic sequence and find the nth term. Recognize geometric sequences and appreciate other sequences that arise. Ratio, proportion, rates of change. Pupils should be taught to change freely between related standard units, for example, time, length, area, volume, capacity, mass. Use scale factors, scale diagrams, and maps. Express one quantity as a fraction of another, where the fraction is less than 1 and greater than 1. Use ratio notation, including reduction to simplest form. Use divide when a given quantity into 2 parts in a given part, or a part-whole ratio. Express the division of a quantity into 2 parts as a ratio. Understand that a multiplicative relationship between 2 quantities can be expressed as a ratio or a fraction. Relate the language of ratios and the associated calculations to arithmetic of fractions and linear functions. Solve problems involving percentage change, including percentage increase, decrease, original value problems, and simple interest in financial mathematics. Solve problems involving direct and inverse proportion, including graphical and algebraic representations. Use compound units such as speed, unit pricing, and density to solve problems. Geometry and measures. Pupils should be taught to derive and apply formulae to calculate and solve problems, including perimeter and area of triangles, parallelograms, trapezia, volume of cuboids, including cubes, and other prisms, including cylinders. Calculate and solve problems, including perimeters of 2D shapes, including circles, areas of circles, and composite shapes. Draw and measure line segments and angles in geometric figures, including interpreting scale drawings. Derive and use the standard ruler and compass constructions, perpendicular bisector of a line segment, constructing a perpendicular to a given line from a given point, bisecting a given angle. Recognize and use the perpendicular distance from a point to a line as the shortest distance to the line. Describe, sketch, and draw using conventional terms and notations, points, lines, parallel lines, perpendicular lines, right angles, regular polygons, and other polygons that are reflectively and rotationally symmetric. Use the standard conventions for labeling the sides and angles of a triangle ABC, and know and use the criteria for congruence of triangles. Derive and illustrate properties of triangles, quadrilaterals, circles, and other plane figures, for example, equal lengths and angles, using appropriate language and technologies. Identify properties of and describe the results of translations, rotations, and reflections applied to given figures. Identify and construct congruent triangles and construct familiar shapes by enlargement with and without coordinate grids. Apply the properties of angles at a point on a straight line, vertically opposite angles. Understand and use the relationship between parallel lines and alternate and corresponding angles. Derive and use the sum of angles in a triangle and use it to deduce the angle sum in any polygon and to derive properties of regular polygons. Apply angle facts, triangle congruence, similar properties of quadrilaterals to derive results about angles and sides, including Pythagoras' theorem, and use known results to obtain simple proofs. Use Pythagoras' theorem and trigonometric ratios in similar triangles to solve problems involving right-angled triangles. Use the properties of faces, surfaces, edges, and vertices of cubes, cuboids, prisms, cylinders, pyramids, cones, and spheres to solve problems in 3D. Interpret mathematical relationships between both algebraic and geometrically. Probability. Pupils should be taught to record, describe, and analyze the frequency of outcomes of simple probability experiments involving randomness, fairness, equally and unequally likely outcomes, using appropriate language and 0-1 probability scale. Understand that the probabilities of all outcomes sum to 1. Enumerate sets and unions, intersections of sets systematically using tables, grids, and Venn diagrams. Generate theoretical sample spaces for single and combined events with equally likely, mutually exclusive outcomes, and use these to calculate theoretical probabilities. Statistics. People should be taught to describe, interpret, and compare observed distributions of a single variable through appropriate graphical representation involving discrete, continuous, and group data, and appropriate measures of central tendency, mean, mode, median, and spread, range, consideration of outliers. Construct and interpret appropriate tables, charts, and diagrams, including frequency tables, bar charts, pie charts, and pictograms for graphical data, and vertical line or bar charts for ungrouped and grouped numerical data. Describe simple mathematical relationships between two variables, bivariate data, in observational and experimental contexts, and illustrate using scattergraphs.